Okay, hi, welcome to another video solution. Today we're going to look at some of these conditional probability questions. We're going to look at one of these really hard ones that involves the drug company and the testing and, whether or not, it's a false positive or not. How do you deal with these questions? So this one you can see a company that performs drug testing guarantees that its test determines a positive result with 97% accuracy, okay? The test also gives 6% false positive. So false positive means the test says you're on drugs even if you're not, right? So it makes a mistake. If 5% of those being tested actually have the drug present in their bloodstream, what is the probability that a person testing positive has actually been using drugs and has not actually just been falsely presented by the test? So what we're going to do for ones like this, and again, these ones are important for the test. We're going to go over ones like this. We're going to start with defining some events here. So we're going to call event A, person using drugs. And then event B is testing positive. Now you can see that it says that if you are using drugs, there's a 97% chance the test catches you, right? So probability of B given A is 97%. Very high chance that you will test positive if you are in fact using drugs. Now there's also another one here, the 6% false positive. So this would be the probability of B, which is testing positive, given that you're not actually using drugs, which is the probability of B given A complement, right? You're not actually using drugs, but you still test positive. Now, it says 5% of those being tested actually have the drug present, right? So maybe this is like it's a medical study or something where they offer a placebo to the other 19 people out of 20 and only 1% or 5% actually has the drug. So let's determine that as well. The probability of A is 0.05, right? So only 5% of people actually have the drug present in their bloodstream. So the question is, what is the probability that a person who tests positive actually has been using drugs, right? Because of course, if you test positive, maybe you actually use drugs and you have the drug and you got, the test found it, or maybe you don't and the test just mistakenly did it by giving you that 6%. One of those 6% false positives. So what we're going to do here is we're going to set up a tree diagram. We're going to start with event A, because as you can see, event A is the primary event here, whether or not you are actually on the drug. And event B, which is whether you test positive, that's going to depend on event A. So let's start with our tree diagram. So we're going to go A, has drug in system. Again, I'm just going to remind you that this is only 0.5%. And then we're going to go with B, does not have drug in system, and this is 95% of people. Now, we have a tree diagram. I just realized this really shouldn't say B, it should say A complement. Sorry. Okay, so A has drug in system, 5% chance. Over here, A complement does not have the drug in system, 95% chance. So now we're going to add the other information we know. The probability of B given A is 0.97. So that's going to go here. Probability of B, so B complement given A, right? So this is, in other words, this is the chance that the person actually has the drug in their system, but the test does not pick it up. And there's a very small chance of that, right? It's only 3% chance that occurs, because 97% chance it got caught, so 3% it doesn't. We go over to the other side. Now we're going to look at the probability of B given A complement, which is the probability that you get the test says you have the drug in your system, even if you don't. And we know from the question there's a 6% chance of that. And then over here we go probability of B complement given A complement, which is that you do not have the drug in your system and the test does not say anything. And we know there's a 94% chance of this because 6% of the time the test is wrong, then 94% of the time the test is right. Now the question here becomes, which one of these, what is the probability that given that you tested positive, so that is probability, of the B event occurring, what are the chances that you actually came from this category of people, that, the drug is actually in your system and you didn't come from this group of people? So what we're going to do here is we're going to multiply down each of these trees to construct the correct probability of these events. So underneath here, I'm going to go 0.97 times 0.05, and then we'll just 0.97 times 0.05. Okay, and we're going to just add a few more decimals here. Sorry, bit of a mistake there. Okay, so the chances that a person picked at random both has the drug in their system and tested positive is a 4% chance that's going to happen, right? If you just pick someone at random. So let's do the other multiplications here. So this one is going to be a 5% chance that the person has the drug, and then only a 3% chance that they do not get detected, right? So 0.03 times 0.05, which is equal to 0.03 times 0.05, which is equal to a very, very small chance, right? Only a 0.1% chance. It's highly unlikely that you could have the drug in your system and not get caught, in this case, not get actually testing positive. Okay, this is 95% of the people who do not have it in their system, but 6% of them will still get tested positive, right, by accident. That's the false positive aspect of the drug. So we go 0.95 times 0.06, and that represents 5.7% of the population. And now, of course, the largest one is over here. It would be the 0.95 times 0.94, which is equal to 89.3% of the population. Okay, so we have all these 4 different categories now at the bottom. And these 4 are important because they all add up to 100%, because they account for every single possibility, right? If we pick a random person, there's 4 possibilities. They have the drug and they test positive. They have the drug and they don't test positive. They don't have the drug and they test positive. They don't have the drug and they don't test positive, right? These are the 4 chances. And the last aspect of this question says, find the probability that a person testing positive has actually been using drugs. So let's add up the probability of testing positive, which is the 2 possibilities that this can happen, right? It's B complement given A, B given A complement plus probability of B given A. These are our 2 ways that a person can test positive, right? They can test positive with the drug or without the drug. So let's add these 2 together now. So this is equal to 0.0485 plus 0.057. Okay, and this is now where we're going to go give our answer. So in other words, this is all the people who have tested positive, right? So let's just let's add those together actually. And and we see that there's 10.55% of the people will test positive according to this drug, even though only 4% of the population actually, or 5% of the population actually has the drug in the system. What we're now going to do to finish this off, the probability of A given B is equal to the probability of A and B divided by the probability of B. Okay, and this comes from just our usual probability formula, the conditional one. So PB we added up here was 1055. Probability of A and B, we come over to this section here. This one down here is, of course, probability of B and A. Because this is if you follow the chain here, right? A happened, then B happened, therefore B and A have happened, which is the 0.0485. So our last step here is just to go. We're going to take the 0.0485. We're going to divide it by the other number we just found, 1055, and we're going to get our actual probability here. 0.0485 divided by and there is our answer. In actuality, if you test positive with this test, there's only a 45% chance that you actually have the drug in your system, right? And this is an interesting result because it shows that even a test that seems very, very accurate, right? If it has this false positive aspect to it, it's entirely possible that the test result is meaningless, right? Now, to look at it the other way, the probability that you don't have the drug in your system, if the test says you don't, is very, very good, right? So these tests are really good for analyzing not having it, not always so good at determining if you actually have it, right? Just kind of an interesting little problem. There's one like this on the test, right? I would suggest you take a look at this question, change the numbers, and then give this one a shot and see if you can follow the chain of reasoning. Feel free to ask any questions as well.